Hi guys, a little tip of the day video on capture method. So capture method is how you create your C-scan. And I've got a C-scan here, which is a large stitched one. It's a flying S with some inserts and some grease down here at the left and stuff like that. And you can see different flaws here. You can see this little light blue here down in the corner. It's a little bit hard to see because of the color. So what I can do is to compress this color scale a little bit. That'll enhance the difference a little bit. But as you can see also, it enhances the squares between this manually stitched area, you know, so you can see the little squares. And there's several tips to kind of remove that. First of all, you can see why it's happening is because you have a little bit of tilted B-scans here, if you will, especially here down at the B-scan horizontal. You can see that they're not completely flat. Now I've put in a feature request on straighten out that, so you can straighten out in the B-scan and hence also in the C-scan. But there are ways of straightening it out in the C-scan, and that's it by going to coverage and gates and threshold. So here's where you do capture method. So there's two ways to improve this. First of all, right now I'm measuring from 0.0 to where I pick up this echo here, and have my gate here set past the penetration echo, and I'm picking up maximum absolute value, which in this case is positive. But I might, since I don't have exactly flat B-scan here, you see I'm a little bit different. I have a different depth measurement here and here. It's 2.9 and 2.88, or left right it'd be 2.98 and 2.83. So it's quite a big difference actually, and that's because of the slanted B-scan. So can't correct it in the B-scan as of now, but if I do instead of depth, which depth measures from 0 to my echo, so 0.0 is defined by the scale here, but if I do thickness, then I'm measuring actually from first echo to second. So if I do that, it takes a few seconds before it reacts, and then this happens for some reason. But anyways, I have to set up my first gate then. So this is the echo I'm measuring from, and then I click on second gate, and then I want to pick up everything inside. Color is different now because instead of my 0.0, I now start my color scale at this point here, which is the maximum absolute value. So I can compensate for that by compressing a little bit. So if I compress to approximately the same color as I had, you can see that these squares that I had, they're gone now, pretty much, and they're a lot better. So you're not seeing in the C-scan these little uneven couplings that you have here. Then the next thing I like to do is to have capture method decide which peak I want to focus on. And if you look at the penetration echo here, then you see it goes up a little bit and then down a lot, and then the echo here goes down a little bit and then up a lot. So these two pulses, if you can look at them, they have different polarity. So if I could either measure from the max negative here to the max positive, or from the max positive to the max negative. That's when you get the correct one. So if I start on the one here, I can see that my negative one is kind of the biggest one, so I want that to always focus on the negative one. And then my second echo here, I want to focus on the positive one. So I go to second gate, and then I click positive, and then you get rid of all this noise. So now if I go from one side on this tile to the other side of the tile, I don't have 0.06 millimeter difference. So that's nice to be aware of when you're inspecting at least the time of flight image. And here's a simple way how you can compensate for uneven coupling. So hope you learned something. I will put out a link for this data set in particular so that you can load it as an FMC file and play with it.